Yeah, and then if you just send us the link, we can post it.
Sure.
And maybe don't quite record yet to get everything else.
I think we did that.
Oh, okay.
Brian's been able to show.
Oh, that's nice. Yeah, maybe do a pod. Urban and Regional Planning Assistant Professor and co-founder of the Spatial Analytics and Visualization Institute at San Jose State, and he expands his research in the applications of geospatial analytical techniques in mapping the U.S. geography of high-tech zones and exploring the role of urban form and equitable, robust knowledge economy in public communities. And he's done a lot of publications and presentations. And then he's before he was with us, he was a clinical assistant professor with an even longer chunk in there of geospatial data analysis at the University of Illinois at Chicago. And then he was also a key member in developing Illinois Map the Count 2020, Illinois' COVID-19 vulnerability, and Chicago's tap water web maps. He's got numerous awards to his credit here, the winner of People's Choice Best Research Award from the Association of Collegiate Schools of Planning, and first place award from the US EPA in the 2015 Campus Greenworks Challenge. And he received his graduate degree at UT.
Thank you very much, Dean Ehrman. Well, good afternoon, everybody. Thank you very much for making sharing your beautiful Friday afternoon with me. I am here to basically appreciate this opportunity to present our center, not my center, Spatial Analytics and Visualization Institute. Dean Ehrman introduced me. I'm Urban and Regional Planning Assistant Professor in the College of Social Sciences and co-founder, co-director of the Spatial Analytics and Visualization Institute. Our center in many aspects is unique. In two aspects that I want to share with you is that we are one of only 10 centers in the SJSU system that provide research, event, and educational activity focused on GIS. And we are one of the only two ones in the capital of tech hub of the world, Silicon Valley. Us and San Francisco, we expand our work to research and event. San Francisco is focused only on education. Our center has a specific mission to advance, promote, inform, assist, and support San Jose State community and also broader community. We focus on spatial analytics and visualization activity. And in order to do that, we've been active since 2021, although we just got approved to be official in research, professional skill building, and knowledge exchange public events with focus on GIS. In my slides today, I have examples of all of them to basically introduce the center, what we've been up to, and also the opportunity to collaborate with colleagues in the College of Engineering. I'm going to start with a few example research that we completed in the center. The first one was mapping the US geography of high-tech zones. The background on the mapping the US geography of high-tech zone is important to consider because urban economy, economic growth, this is always the goal of metropolitan planning organization, economic development officials, transportation agencies. They want to have more economic growth. Because of that desire among the cities and the rise of knowledge-based economy after 1980s, there were multiple economic development strategies came out, such as innovation district, innovation cluster, knowledge-based urban development, innovation ecosystem, that they all presented a mix of urban development activities and also some factors that firms, they have more role. For instance, clustering, firms, cluster of firms of creative cultural economy or high-tech. Urban life amenities, mixed-use development, walkability, which are attractive to more educated or talented human capital or talented millennials. Most of them, they have all of these aspects in common, but when you categorize them, some of them are in the place quality indicators, such as walkability, language diversity, or whatever goes to urban form, and some of them, they go to the clustering of the firms. Their ultimate goal is to attract more firms, whether they are in high-tech industries or they are in what another line of industries cultural creative economy that we don't get into that. Having those firms in the area, being more productive and also having more innovation in the area. So innovation productivity and firm productivity, they are in line with economic growth and growth of GDP in the areas and the goal that folks they want to have. The background of all of this economic development strategies, they're more of the theoretical framework, which needs more empirical evidence to look at, basically test some of them, whether those dynamics and synergies exist, and what are some of the ripple effects of too much focus on these economic development strategies. Let me give you an example. These strategies, they mostly talk about neighborhood level development of mixed use area, very walkable, high density at a neighborhood level that could basically centered around an anchor, which could be a headquarter or university. But when we talk about development, particularly urban development, scale matters. Is it a neighborhood? Is it a city? Is it a regional development? Which type of scale are we talking about? And at which scale does this have impact? Which was the goal of the first study that we did. The use of mapping and GIS, we used 26 indicators to measure built environment. Those 26 indicators, they were categorized within 4 categories of development density, land use diversity, active centering, which is basically having the dense area at the center and then slowly sprawling out, and also street connectivity, which when your parcels are smaller, you have a higher street connectivity, it's more walkable, people feel safer, and versus when you go to basically sprawled areas, you will see the parcels are bigger. Combining these factors together, we came up with a score, urban compact. So when all of them, they increase, we have more compacted area. When they decrease, we have more of the sprawling area. We measured compactness at the neighborhood level, let's say 4th Street to 10th Street. And also we measured them at the regional level, 9 counties of the Bay Area. We wanted to see which scale matters for innovation productivity. On the other hand, we had a measure of innovation productivity, which was the number of awards that the Small Business Administration gave for innovative activity through SVI and STTR. And we ran the analysis. Interestingly, compactness index at the neighborhood level had a negative correlation with innovation productivity. However, it has a very strong positive correlation at the regional level. We know that the clustering, the agglomeration of economies of clustering is a major force of firms to get closer to each other because they share resources, they can push their agenda to policymakers in the area when they have more of them. The result was shown that actually compactness was stronger than clustering at the regional level. This makes sense because literature has a vast evidence that there is a connection with property value premium and compactness at the neighborhood level, but at the regional level, compactness supports easy access, supports a strong presence of public transit. So this talks about the fact that most of these economic development strategies that they focus on neighborhood level, they might also have a ripple effect on the property value premium. And also, the other basically phenomenon behind the scene was that these factors of compactness, they need to be basically mediated by the presence of firms in order to produce the innovation productivity. And in the other path analysis that we conducted, we proved that the presence of high-tech firms and creative firms, they are connected to basically transit accessibility and walkability of the area. Because I have 48 slides, I want to push so fast. How many of you are familiar with transit-oriented? I know you are transit-oriented development. So transit-oriented development came on board in order to support transit usage, right? To basically encourage people, if they're living in the station area, to use transit instead of cars. So the initial idea was not economic growth, was not economic development, was not innovation productivity or firm level productivity. It was decreasing the GHG emission from cars and increasing the use of transit. In other words, having, let's see if I'm recording actually the slides, which I hope. Yes, I am. Which is talking about this a development that is supporting the use of trans. TOD, it has different definition, but objective definition of it is the type of development within the station areas that's dense enough, walkable enough, and land and mixed use enough for folks to live in that area, have all of their demands addressed, and also they can have access to another transit stations. So walkability, land use diversity, and density are major factors of transit-oriented development. We wanted to use this idea of TOD, assessing the economic outcomes of the built environment, to connect it with the firm sales volume. We purchased firm level data for the entire United States. We had the transit station areas for the entire United States as well. We measured density, land use diversity, and walkability, ran through clustering, and clustering gave us 3 types of stations. TOD, which you see in the example from Chicago, is very dense, small parcels, pretty walkable, and also land use diverse. Going to hybrid, which is something in between, you still see the land use diversity, commercial on the first floor, residential on top floor, a small parcel, but not that type of density, going all the way to a land that happened to be next to a station. There is no coordination between the station and basically transit, which we call them transit adjacent development, accidental presence of a station. We accounted for the indicators of prudential function theory, which includes inputs such as labor, capital structure, the type of assets that they have, and the level of the firm, whether it's a headquarters or a plant or so forth and so on. Ran it after matching all of the firms in the station area. The result was showing that firms in TOD, they are 2.5 times more productive, selling 2.5 times more than those ones that they're in TAD and hybrid. And also hybrids are also 2 times productive than those in TAD. Going back to talking about that when we talk about compactness at the neighborhood level versus at the regional level, we found it to be more effective. In order to have a higher compactness at the regional level, it means that we need to have more TODs spread out at the region, that those nodes could be connected to each other through transit line or some sort of non-auto transportation. And this talks about the use of hybrid, identifying hybrid station areas, and then match them with other capitals or capacities of the area for the future innovation district that the folks want to focus on. Throughout my PhD time, I worked with a couple of cities in Texas, in San Luis, that they wanted to develop innovation district. This idea of innovation district came after Silicon Valley. Then everybody around the US and also around the world, they wanted to become Silicon Valley, right? But the point that maybe, at least through my communication with folks in economic development office in the 2 cities that I worked with, is that it's sort of like being less considered, is that firms naturally cluster together. So if we want to have a specific development in an area and then push the firms to cluster together in that area, maybe you are not focusing on where the firms are already clustered. And that was the case in one of the projects that we were working on, that the area designated for innovation district was totally far from any cluster. We were asked to develop a firm cluster for that area. That came me to the idea of that, well, now that the entire cities, most of the cities around the US, they are looking into innovation district and they don't know where are the high-tech clusters, this is the need. Also, knowing those clusters will help with many ripple effects that these firms might bring in, such as congestion, such as land value. So when we know where they are, we could basically put the smart growth policies and dedicate the smart growth policies in those areas to answer most of them. It's not going through the methodology in detail. We had the firm level data. We divided urbanized areas of 52 large regions in the United States to small hexagons of 0.3 square mile. We developed a new score that was accounting for employment and number of firms of high-tech. We ran it through hotspot analysis and we got the clusters of firms. 52 largest regions in the United States. We validated 10 regions with local experts that they looked at our map and, oh, yeah, that makes sense. We should have this guy here. This is the headquarters. And also when looking at the data, we saw that in each region, more than 50% of high-tech employees, high-tech firms, and high-tech headquarters, they are located in high-tech clusters. So it got validated. In terms of the next step, was now that we know those high-tech firms, we need to identify their sectoral typology because there are different location dynamics based on the industry. Because they have different type of people that they work there, they have different type of needs that they have. Let me give you an example. The production service, the professional services that they mostly focus on consultation, they don't need the equipment for manufacturing. Therefore, they could be in the more dense area that they are further away from freeways versus those ones that they are focused on manufacturing. Using the census definition of high-tech industries, which includes professional services, which is IT and engineering consultation, no manufacturing, R&D, IT manufacturing, communication tech and equipment, aka semiconductors, biopharmaceutical, and our space. When we look at the entire United States, more than 61.6 or almost 62% of the clusters, they had a diverse array of these firms. The next one is the professional services. Almost 30% of the clusters they had, they were focused on professional services. Few they were focused on R&D services and some R&D, IT manufacturing and semiconductor and biopharmaceutical, which is the focus of most of the innovation strategy, has the lowest number of clusters in the United States, because when we look at the firms, most of the firms in the United States are professional services. So there might be need for more basically support for startups. But when we look at the profile of the 52 regions that we used for identifying the geography of high-tech zones, as you see, Los Angeles has the highest number. For those folks that they are familiar with urban form, polycentric versus monocentric. When the employment node or economic nodes are scattered throughout the region, it is a polycentric type of region. And when they are clustered in one area, it's called monocentric. LA in the literature was found to be a polycentric region. And that polycentricity and monocentricity is mostly used for the transportation network and transit. LA was one of the cases that was interesting to take a look because of the highest number of high-tech clusters, and also the regions that they have R&D and biotechs, they were interesting to take a look because we have a few of them. Let's first take a look at Los Angeles. In Los Angeles, these boundaries are basically the most granular level of the cluster of high-tech firms. As you see, they are scattered throughout the LA County, and also not only LA County, they get to Bakersfield, they spilled over to Bakersfield, they spilled over to Riverside on the other hand. And also most of all of the airports happen to be in a high-tech cluster. All of the downtowns also happen to be a high-tech cluster. So there are some urban forms and some place qualities that you can find out of these high-tech clusters. Was one of them. And then the other thing was when we are talking about these high-tech clusters are the center of jobs. Folks, they need to go work there and they need to live somewhere else. Job population balancing balance, right? The boundary of the regions are based on the economic activities. If the high-tech clusters in these regions, folks are living in the other region or the other way around, which region is responsible for that high-tech cluster? Then we have a very scattered situation. Who should put infrastructure for those ones? Then we go to the mega region. Rethinking the map of the United States from mega regions, that is a conversation in US DOT, which happened to be actually matching the boundary of my high-tech clusters, the scatter of those ones. The other example, we saw that the pharmaceutical cluster, there are very few in the United States. We saw that there was a conversation, but earlier I said that these focusing on innovation district without knowing the high-tech clusters might be difficult, but in some cases, some regions, they don't have high-tech clusters that much. So they can think about developing an innovation district and use that as a generator for innovation district, right? A good example of it is Cortex Innovation Community, which is one of the most successful innovation community and one of the oldest innovation districts in the United States, which happened to be one of my high-tech clusters, which is focused on pharmaceutical. For one of my projects, I had to go there and basically validate my work. And that's true because this innovation district was basically anchored by a major university, Washington University. And that's why that they are growing innovation, Cortex Innovation Committee, and they got to be, recently they got a new line of transit station and they became a Ph.D.
Question, is that an acronym? or
No,
is it really
the
a
acronym is CIC, Cortex
Yeah.
Innovation Community,
Cortex itself, like. brain?
maybe.
Okay. If they have a very strong medical school.
Yeah, they have actually, they have more than one. I think WashU is the strongest, and they have another one that's there. And that's interesting because state put money to innovation to support faculty to open their own startups in a co-op building, major CIC co-op building, which is very close to WashU. So they get the working space in return of, they do lots of cool things for a knowledge exchange and having folks talk to each other. And if you know Venture Cafe was something that started in Boston. Cortex has one of them. It's a cafe that folks, they get together on Fridays usually, and they don't bring business cards. They don't introduce each other. They try to get connected with each other, and then on the line of connection, then they would introduce themselves and expertise. It's more of the situation to let folks interact. Our own Bay Area is more monocentric, Midland Airport and San Francisco downtown and Oakland downtown are homes to high-tech clusters versus DFW, which is more a scattered area. I use these two areas to look at the transportation infrastructure qualities around the high-tech clusters. As well, professional services are found to be in the areas that they are more transit-friendly and more walkable. On the other hand, aerospace and IT manufacturing, they found to be closer to the freeway entrance, and also airport, which makes sense because for their freight mobility, they would need access to airport versus professional services. They don't need that much of basically long distance freight activity. There are other concerning points around high-tech clusters, which when we look at the entire nation, we see is that the severe job population imbalance, which in high-tech clusters, we have more than 50% of the high-tech employees, firms, and quarters are living, but less than 7% of a region population is living. So very strong place of work, not a livable place. Job population imbalance, traffic congestion. Job population imbalance, let me summarize this and move on to my next example. Job population imbalance was one of the major concerns in this growing knowledge-based economy when we focus on high-tech clusters, mega-regional access and mega-regional allocation of funding and policy decision was another fact that we found. IT, aerospace, and bio were found to be more in auto-oriented and suburbs versus professional services in walkable and transit-accessible areas because of their different type of people that work for them and the different type of needs that they have, which then in that case, mixing up the sectors of the clusters might produce the need for more transit use. And showing the fact that how much of money we are wasting in Bay Area on the congestion. On SAVI website, under the research tab, you can access the map of the geography of high-tech clusters in the United States, and the contents from my book, which looked at the urban high-tech zones, was finished, and that will come out, and that will have a closer look at all of the high-tech clusters in an Elsevier publication. Looking at the public health outcome of the built environment, we talked about the way that TODs are defined and how we can use them. Again, TOD came up in order to support the transits. The other basically outcomes came after curiosity of the junior faculty, that they wanted to look at what other outcomes they could have. For those of you who are familiar with the crime prevention through environmental design, which supports more eyes on the street. And the logic is that the more eyes on the street we have through density, walkability, and land use diversity, we have fewer crimes to happen. On the other hand, when we have more people, there are more victims, potential victims, and there is a higher chance when we have more folks on the area that they basically be the target of offenders. We looked at Chicago, we looked at Ontario stations. Chicago was one of the areas that we looked in the earlier project. We expanded the factors that they could basically be used in defining TOD, because here we were looking at the crime and public health. In addition to density, land use diversity, we also looked at the frequency of the transit. And we also took a look at the micromobility, the use of e-bike and scooters to basically account for not only walker, also more basically those who are using active mobility. After categorizing this round, we came up with 4 type of station areas, which not that much different. TOD was divided to 2. One CBD TOD or central business district, which is denser. Then one is about regular TOD, hybrid, and TAD, which I discussed the definition earlier. Example of CBD TOD, you see pretty dense, land use diverse, small parcels, walkable. Regular TOD, high density, not that much of land use diversity. Hybrid, mixed use, not very dense. And TAD, that happens to be just a empty land next to a station. We looked at the co-founding variables that could affect the crime and in those areas, and we see that there are quite a difference. So methodologically, we needed to run the propensity score matching to basically match them. But I want to basically get to this point that in the first look, the general perception, which here is about exists as well, is that CBDs are very unsafe. And also that was the case in Chicago. But when we narrow it down to the very similar neighborhoods in terms of characters, our result actually showed that CBD in Chicago are the safest. And when we look at, when we run the propensity score matching, we run the propensity score matching, match them, and then go through looking at the difference. Violent, robbery, and burglary, they were all lower in CBD TOD. So CBD TOD was found to be the safest. On the other hand, TODs, they found to be the least safe, and hybrid came after CBD TOD. So basically CBD TOD the safest, hybrid, TOD, and TAD. So what it talks about is that if we mess up with those factors, like increase density, but not give it land use diversity, it doesn't get to the fact of having more folks out. So this result was basically showing that the land use diversity of the TODs has the impact on the crime. When you have TOD and hybrid, which they had the high land use diversity, and they were found to be the safest, that has the impact on crime. Why does it matter? Because folks are not using transit because they're afraid of crime. So if we make sure that our transit are safe, our station areas are safe, it could be encouraging folks to use them, which this research showed that increasing mixed use diversity in the station areas will bring more folks to that area. And basically more eyes on the street and station. The last project is the project that was funded through Minnesota Transportation Institute and Ford Mobility, which they have a program, mobility data for safer street. We were among 6 recipients of the grant from Spain to look at the bike equity challenge in our beloved city of San Jose. San Jose has been active in becoming a paradise for bikers. They always wanted to be a very bike-friendly area, started from 1997, if I'm not mistaken, up till now. If you take a look at the city without considering classes or need, you would see, wow, city of San Jose is well covered by the bike network. And if I get the bike, I can go wherever I want. But if you want to bike, or if you want to have your kid bike, would you ask your kid to bike somewhere that's safe? A bike lane that is buffered and separated by a sort of boulevard from the street, or would you ask that person to go and bike on a shared bike route that there is any chance that the car would hit that person? These bike routes, they are not only used for bikes, they're used for scooters, they're used for active mobility, runners they are using. So what we did here, which was a quite bit different from literature, was take into account these different classes that we basically have them defined in the APTA definition. Bike class 4 got the highest weight. I can go through the. So it's the background 1970 bike plan, and then 2020 it went up. But let me back up a little bit and give you a little bit of historic racial segregation and the spatial segregation that we have in the city of San Jose. When we look at the racial segregation, always east was different from west. No, this is, I think it's 2010. Yeah.
Okay, still waiting for
I think this is the 2020. And the segregation is still exists. Basically, San Jose is divided by 101. East, more of the Hispanic folks, Asian folks, low income, low property value, and on the west, high income, high property value, and then higher presence of white residents. Our major question that was that can we find the relation between this and the bike equity again and the infrastructure being bad? Are we gonna find bike paradise in the West San Jose and bike desert in East San Jose? And let me introduce the idea of bike paradise and bike desert that we came up with in this basically project. For all of the census blocks in the city of San Jose, we defined the area that they could be bikeable. They collected all of the bike lane, developed a new basically measure of bike lane per capita, but we weighted them by the type of the class that they have. And if it was class 4, which was completely separated at boulevard, was getting the highest weight. If it was just a share, it was getting the lowest. And then running through hotspot analysis, the areas that they had the lowest value, they found to be bike desert, and the areas that they had the highest value, they found to be bike paradise. Well, when you look at the score, not city of San Jose is not actually well covered. But if you go back to the map of the bike lane that I showed you, it's not that much of the case. And also, again, East San Jose is place to bike desert, and West San Jose is place to bike paradise. Best bike infrastructure developed in the area. When we overlap that with the socioeconomic and characteristics, yes, more of the Hispanic and Asian folks, although when we look at the entire city of San Jose, they have a very strong presence and a strong share of residents in city of San Jose, but they get the poorest bike infrastructure when it comes to the bike network. Also, when we look at income and percentage of bike, again, bike is a low income and low property value. Median housing value and so the next question was, okay, city is going to tell us that, okay, we will provide the bike lanes. Are they going to use? We use the street light data, which has the travel behavior of the folks to basically see if there is a correlation between bike use and our bike score. And interestingly, the result was showing that there is a strong connection, there is a strong correlation, which by 1% increase in our bike score, there was 20% increase in the use of bike, not bike use per capita. Yes, in the bike use per capita. So there was a correlation between our score worse than that, there was 1% increase in the sidewalk length per capita correlated 75% increase in the use of bike or car, which could result in accident. And again, San Jose BEI map or San Jose Bike Equity map is also available on, is another tool that's available on SAVI's website. And also we have a pending grant to expand it to the entire state of California. That was a short example of a type of research that we have. I have to rush up before we run out of time. I want to show you other activities that we've been up to. We are also active in professional skill building. We launched our paid workshop last semester. It's quite a work to get a page in San Jose State that folks can pay and everything. But we got that website. It took 3 months, but the website now is built, and I just need to just edit it a little bit between all the recordings there to basically have these workshops every last semester, because I was quite busy with the paperwork of the website to run it, I recruited folks from both on campus and off campus. If you know, at the College of Business, Oyan, Associate Director of Research in our center, they taught 2 workshops, and Catherine did a fantastic job on QGIS, Priyanka was, and Bahar Biazar, Python, R, QGIS, statistical modeling, and drone mapping. The workshop, they got sold out. We are planning to do it again definitely, and this is one line of collaboration opportunity with colleagues from College of Engineering that they could offer basically workshop, and again, they are paid workshop. And we also have been active since I joined San Jose State in doing more public events, and that's another line that I hope to be basically fortunate to work with colleagues from College of Engineering. We host SJS Day every November 17. Every year, we were able to basically raise funds for students and basically give them award for their participation. And also we have a good line of the speakers which match with the basically societal issues. For instance, in 2020, our concern was election. So we had the speaker from MIT Election Data and Science Lab with the talk of basically use of GIS and mapping to look at the accuracy of the election. And in addition, SAVI talk, which is basically, it happens 2 times a semester. We have a speaker who will talk about map and spatial analytics and visualization techniques related to different topics. We could basically build a network of, a very good network of folks who attend our SAVI talk. Last round, we had, I think, 80 people who attended from across the United States for our talks. That's another opportunity that I would love to basically collaborate with colleagues from College of Engineering. This is our website, and the website is also on San Jose State and also on the URBP department website. So if there is any question, all yours.
Question, you related the in Chicago area, let's say that you related the crime rate versus the population or the use of the walkable Zoom and things like that. Have you taken into consideration of people's intervention? How many people, percentage of people who even though exist in the area during the rush hour, how many people are willing to intervene when a crime is actually happened?
So this is a question that I got from reviewers on the paper too. So the definition of activity density that we used was employment plus population density. So it was accounting for, it does not account for a specific time when basically the station areas empties or they get filled up, but because it has the employment population density, it's a density that is consistent throughout the day. Does that make sense?
Yeah, there's something that comes along with the police reporting that would give an indication of a bystander intervention or something.
No,
like
well,
that.
that's an exercise.
I think that would be interesting,
Yeah,
and
I know.
additional data to consider.
Yeah. I know one of my students in Chicago was using the reports, but this is good actually. Yeah, I'll take a look at the report. I think that's.
Yeah, yeah,
Seven.
a lot of the departments are subscribing to these services, like I think it's crimemapping.com or something like that, where they'll post, for the, I mean, they have reporting requirements.
Oh, let me correct myself, that my crime data was from the report. Was from the map, but not the calls. So they were just reported crime.
Okay.
Not-
But not taking into the interventions or relating to the walkable route, the bike lane and all that kind of stuff.
Yeah.
Okay. I lived in suburban Chicago before, so,
Oh.
so I know the route a little bit when you show the stations and all that.
So it's good. Did that make sense to you?
Well, that was like a 30-something years ago in Naperville, suburban Chicago area. But Chicago is a metropolitan area,
Yeah.
it's pretty big.
Yeah,
And
and
then-
which takes it all the way into, for example, you would see all those types of stations.
Yeah.
Right.
Yeah.
Well, I did take a train from suburb area to downtown to Chicago.
And there are other things that it basically differs among the stations. Sometimes the stations are on a street or like elevated versus those ones that they go underground.
Right, right.
So those ones that they go underground, they get less language diversity score in my station typology, and they happen to be those ones that they are least safe.
Oh, they
Versus
go
those ones
underground?
that-
Why do you think?
I think maybe because it doesn't get that much of eyes on the station, so those ones that they are elevated in Chicago, they are usually, if they are in that dense area,
Yeah,
they have buildings, so they're
They got raised in the platform.
yeah. Yeah, so I just came back from the District of Columbia and they are having a crime spike on their public transportation of some pretty shockingly violent people pulling out guns, stuff like
Yeah.
that. So I'm kind of pondering that. I mean, the buses don't go underground, but the metro station. Now I'm gonna want to go back. Which metro was it?
No, yeah, and then that's the deterrent to use the transit station, and then the transit, they go bankrupt, like people don't use it.
Yeah, well, that's exactly what's happened, because between the work from home and then what, anecdotal, because I was only there for less than a week, but the buzz about, oh, it's so unsafe now from my neighbors.
Mhm.
The two forces are combining to me to give a much lower density of people on the train and on the bus, which is great if you want to sit.
Yeah,
It's not
but
great if you're
it's not great for the
worried about,
agency
yeah.
or maintenance or getting money to basically change the chairs, bring
Oh, yeah.
more
no,
cars.
there's death spirals happening for transit agencies all over the US right now. It varies.
And that basically motivated the project for Chicago. So I really wanted to see if the CBD is that unsafe, if we really compare it with the very, very similar neighborhoods.
I have a question about your first work on the cluster economy. And it probably would take like a whole another hour to talk about, maybe we can do that, but just big picture, if you were to go and redo your analyses that you did, now that we have a lot more work from home, because I mean, that's just a general question, is how much does physical proximity matter? And it's been happening for some time now, but the pandemic just really sent people home and not everybody's coming back.
The placelessness.
Yeah.
That's actually, that's a concern. The number of employees, the problem here is that the number of employees that they report is the number of employees. I might have taken the number of employees out and would just use the number of reps. Because if they have, let's say, 20 employees and 10 of them are working from home. So basically, it's not, and maybe employment size is not a very good input.
Yeah, what we
Maybe.
need is kind of butt and seat in office.
Yeah.
Probably still cool. Okay. But yeah, but anyway,
And also, I think in the new data, I have to go back, when I was back in Chicago, the new data set was released and they had some indicators of this, like how many of them worked online. I have to go back and see what was the definition. the primary worker or something like that.
Yeah,
Say-
yeah, but I would suspect also companies may not be willing to disclose too much.
Yeah, yeah,
That's
I
not
think,
required for reporting purposes.
I think they get those information from insurance. And then they,
Like, this whole thing, but yeah, the work that you do trying to get the quality data.
it is, and, yeah.
Maybe I missed something, is Silicon Valley an exception or not? I think you mentioned three most innovative cities, New York City, Los Angeles, and about the third one. I don't think it includes our area. Also, you mentioned that the transit and also walkability were primary indicator of innovation hub. But Silicon Valley is not known for either.
No,
I'm actually concerned about the use of SBIR and SPTR in regions where you have a high influx of venture capital, because I think we just don't write a lot of these grants because the money's hard to get and you only get this much.
yeah,
And you can go down the street.
it's innovation
We should
project.
definitely-
Innovation
talk.
productivity was one of the things that it was not easy to get the ground level data on it. Or if like get the patents and patents, they were not available below zip code.
So I've seen the science paper with the patents by geography, but that's problematic because it's your home address.
Oh, so it's not the, okay, it's not
So
the employers.
You know, and nobody lives there, and so then, you don't really get the density. Anyway, so yeah, I actually would love to talk to you more. I have to get upstairs for a meeting
Sure.
with Maggie Barrera, but.
Sure. we'll be in touch.
I have this class that I taught on. Talk.
Of course, of course. Thank you very much. Thank you very much for taking the opportunity.
Would your slides be available to us?
Yes, I'll share it.
Yeah, because some of the data is very
All that
interesting.
information.
Want to take a look at it?
That is-
Sure.
I can just see your.
I will also. send the
Mine's
papers.
too slow now.
Just try to catch up to one percent.
Yeah, no, but honestly, your approach, just even with the expertise in this room, like I'm sure Anand is buzzing about the biotech. Why didn't San Francisco show up, like South San Francisco, right? Like, there's just questions about this where having more technologists could really be fun for us to work
Yes.
with you.
Definitely, definitely. It's a matter of clustering. So if they're scattered, they don't pop up. Like if you have one or two firms in those areas, they might not pop up.
But I mean, if one of those firms is Genentech, and then there's a whole bunch of satellites around it, and then in Emeryville, there's a whole bunch of biotech. Anyway, but again, we're not done.
Just the starting point. Yeah.
Yeah.
Sure. Yeah, well, the Silicon Valley, as you mentioned, maybe the biotech one. We have to look at the data, but the major part that came out was the San Jose.
Yeah.
Around the, stretch from airport to downtown.
Yeah, that's really interesting. That's actually, me. I guess maybe I just go by the signs on the freeway. I wouldn't have pegged it. So, yeah, the data, the data. Yeah.
Sure, so also for other collaboration on the event and workshop, I'll be in touch.
Plus, whatever you have, and then
Sure.
we'll just push it out to our folks through newsletters, because we have a fact staff and a student newsletter.
Sure,
Yeah,
definitely.
and we're gonna really try with the people you met, Ali and with Indu to really get some excitement going. That's the best place, I think, to start, but even the industrial systems engineering folks would really love this.